lecture, we look at deployment models and delivery models of cloud computing. So we already have seen overview of cloud computing. It has 5 components: resources, which are servers, networks, service and applications. Then there were 5 defining attributes or essential characteristics which were given by NIST, that were on-demand self-service, broad network access, resource pooling, rapid elasticity and metered service. We've already covered these 2 points in previous lectures. Next was a deployment model. There are 4 models which are public, private, community and hybrid cloud. Then there were 3 delivery models, which is software as a service, platform as a service and infrastructure as a service. And finally, the 5th one was infrastructure, that was distributed infrastructure, resource virtualization and autonomous systems. So we've already looked at these first 2 points, and today in this lecture we'll be covering deployment models, 4 deployment models and 3 delivery models of cloud computing. So let us look at the deployment models first. So the first one is public cloud. So in public cloud, the cloud infrastructure is provisioned for open use by general public on pay-as-you-go manner. So that means any firm, industry, organization or individual user, they use the cloud computing services provided by a third-party cloud provider over a public network, and it is generally available to all, right? And it is invoiced on what is used. So basically that is what is meant by pay as you go. So if you look at this infrastructure, here exists on the premises of the third-party cloud provider. So the infrastructure exists on the cloud provider, services are provided by that cloud provider, and the cloud resources are shared among all the users. Therefore, it is economical. Some examples of cloud providers offering a public cloud are Amazon Web Service, Microsoft Azure is example of a public cloud. Now let us see suitability of this deployment model. Public cloud is suitable for users who want cloud infrastructure for deployment and testing of applications. It is also suitable for hosting applications in cloud to serve large workload without upfront cost. So there is no upfront cost involved, and it is suitable for hosting applications where that application has to be offered to large number of users. Private cloud. So what happens in private cloud? A single organization, so this cloud is meant for only a single organization. So that organization will own the servers or the data centers, and the service of that is also meant for the users associated to that particular organization. So the cloud infrastructure is provisioned for exclusive use by a single organization. It is a client owned and managed. That means the data centers will be owned by the client and they'll be also managed by the client. And its access is limited to the owning clients and their partners. So only those users which are associated with that particular organization will be able to access that cloud. Unlike a public cloud, its deployment is not meant to sell capacity over internet through publicly accessible interface. It is built within the domain of an intranet owned by a single organization. So if you see that services and infrastructure are maintained on a private network, on a private cloud. So let us see that what is the suitability of this deployment model. It is suitable for the application where security is very important. institutes like government and banks that have very sensitive data, that have high security, privacy, and regulatory concern, they prefer to build and use their own private clouds. It is also suitable for users who want to have a very tight control over their sensitive data. So the difference between public cloud and private cloud is that a public cloud is open for all, and there the data center is owned and managed by a cloud provider, whereas in private cloud the data center is managed and owned by a single organization, and the services of the cloud are also meant for all the users which are associated to that organization. So let us also look at the concept of virtual private cloud. What we just discussed is also is physical private cloud. So in what happens in a virtual private cloud, though the cloud infrastructure is provisioned exclusively for the use by a single organization or the users associated with that particular organization, but it is hosted by a third party. That means the data centers and the servers will be located off premises. In physical private cloud, they were located on premises within the user's intranet, but in virtual private cloud, they are hosted by a third party, that is, they are located off premises. So let us look at this. Cloud provider dedicates a set of computing resources for a specific customer. Cloud provider maintains the infrastructure. It provides service over virtual private network, VPN. So that means so the data center will be off premises. It will be it will be maintained by a cloud provider, but in that data center there will be certain resources which will be reserved for a specific customer, and they will be accessed over a virtual private network by the user from outside. So virtual refers to the fact that physical infrastructure constitutes the private cloud is situated off premises. So basically that is why it is called virtual, because the data center is not physically present in the premises of the user. So it is situated off premises, and it is accessed through a virtual private network, VPN. Some examples of service providers who provide virtual private cloud VPC over VPN are Amazon, IBM, Azure, Google. In fact, all of them provide VPC. Next, let us look at what a community cloud is. So the cloud infrastructure is provisioned for exclusive use by a specific community of consumers that have shared concern. For example, mission or a security requirement or a policy or some compliance consideration. Right. For example, let us take an example for this. Let us say that we have these NCC units which are existing in every school and universities. So NCC is one community. They can have their own community cloud, and the NCC units in every nook and corner of the country can access, every user of that can access the community cloud. And what is it? What is it bound by? These users are bound by a common mission, which is NCC. Mission, or maybe we can say a common organization, which is NCC. Or it can be used by users which have similar kind of security requirements, or maybe a policy, right? So this community cloud in this data center can be owned, managed, and operated by one or more organizations in the community, a third party, or some a combination of that. So it's very flexible. So either it might be in It might be owned and managed by the cloud provider, or it can be on the premises of one of the users of this community. So it may exist on or off premises. So let us see the suitability of community cloud. So organizations that want to access same kind of data and applications and want the cloud cost to be shared with the larger groups, for them it is very apt. So let's move ahead and look at another model, which is hybrid cloud. So the cloud in hybrid cloud, the cloud infrastructure is composed of two or more distinct cloud infrastructure, which is private, community, or public. So basically, hybrid cloud is nothing but combination of private, public, or private and community cloud. So private cloud is supplemented with computing facility from a public cloud. So let us first understand this. What does a hybrid cloud means? So let us suppose that there is an organization which has very sensitive data. So they have their data center in place on the premises, which is maintained, managed, and owned by them. That is, they have a private cloud. Now, this organization, let us say, develops an application which they need to put up for testing. That means they need to give access of this application to a large number of users. So what can they do is they can uh, temporarily rent some resources from public cloud. So this is a combination of private cloud and public cloud. Or what can happen is, another example is, then an organization want to store a lot of data. It can store the sensitive data on its own data center, which is on its premises, and it can store the other data which is not so sensitive on the public cloud. So basically, if you see, and it can also be used for hybrid cloud can also be created in case there is a spike in the load. So suddenly some lot of resources are required, and the on-site data center cannot cater to that much request for the resources. So it is temporarily handled by public cloud. This is known as cloud bursting. Let us look at this. Private cloud is supplemented with computing facility from public cloud. So the private cloud is already there, and it will be the resources will be added on from a public cloud. This approach of temporarily renting capacity to handle spike in load is known as cloud bursting. So this is the suitability of hybrid cloud. So it is suitable for those users who want to take advantage of secured hosting on a private cloud, and also the cost saving due to shared hosting in a public cloud. So we have seen 4 deployment models: public, in which is open for all; private, which is only for particular organizations and users of that organization; community cloud, which is for multiple firms, users, organizations, but they are bounded by some kind of they have some common mission or policy due to which they come together and create a cloud; or a hybrid cloud, which is a combination of any 3 of these. And we have also seen the suitability of each of these deployment models. Now let us look at the delivery models of cloud computing. There are 3 major categories of delivery model. So service can be broadly classified into software as a service, platform as a service, and infrastructure as a service. Let us look at some definitions before looking at these 3 delivery models in detail. First is service. So service is a mechanism that is capable of providing one or more functionalities. So I'll say a well-defined functionality. which it is possible to use in compliance with provider defined restrictions and rules through an interface like web. So service is something which is very well defined. It has a well defined functionality or functionalities, well defined inputs and outputs, and it can be accessed through an interface. A platform. So a platform is a fundamental computer system that includes hardware equipment. It also includes operating system, and it might also include application development tools and user interface on which the applications can be deployed or executed. So an example of a platform, let's say, is a Google App Engine. Google App Engine is a platform which is provided on cloud. So Google App Engine allows the user to build and deploy the applications. So it gives them the hardware on and the operating system and maybe the application development tools which are required for developing and launching the application. Lastly, infrastructure. So let us look at this definition, that what do we mean by infrastructure? Finally, infrastructure. So let us look at this definition, that is what is meant by infrastructure. So infrastructure refers to underlying physical components that are required for a system to perform its functionalities. So what would infrastructure refer to in IT system, or it will refer to a processor, storage, network equipment, and in some cases also database management system and operating systems. So we have seen three definitions: what is a service, what is a platform, and what is an infrastructure. Now let us see the three delivery models. First, software as a service. So the capability provided to the user is to use the provider's application running on cloud infrastructure. So when software is being provided as a service, then what is being provided to the user is the capability to use an application which is stored in one of the servers in the data center. So the application is owned and managed by the cloud computing provider. And what does user do? User will simply access that particular application and use it. So this is called as software as a service. The applications are platform independent and are accessible from various client devices through interfaces such as web browser or APIs, that is program interfaces, application program interfaces. So they are independent of the platform, independent of the hardware on which it has been created. It has to be, if the accessibility is to be provided to a large number of users, then the applications must be program independent. And they are accessible from various client devices, can be accessible through mobile, a tablet, laptop, desktop, or any other device which the user has and is connected to the, but the only condition is that device should be web enabled. Next, consumers are increasingly shifting from locally installed computer programs to online software services that offer same functionalities as it reduces the burden of software maintenance for customers. So example of software as a service is Gmail, Microsoft Office 365, you have Google Sheets, and many others. So if you see that software as a service, almost every one of us uses this delivery model of cloud computing. It has a wide market share with consumers and is more efficient than perpetual license offering model that many software vendors do. So, for example, instead of using Microsoft Office Excel, I can use Google Sheets. So those, if I have a huge sheet, that will be stored on the cloud, and I can use it, and it gives me the same functionalities. So to sum up, software as a service, that is SaaS. It's also known as in short SaaS. Um, it is the software which is provided by a third-party cloud provider who hosts and maintains the application in a data center and offers it to the user online. So in software as a service, the consumer does not manage or control the underlying cloud infrastructure, that is network, servers, operating system, storage, individual application capabilities. It can only use that particular application. So what does user do? It can have use and maybe have a limited control over user specific application configuration settings. So it cannot change any other setting excepting maybe some of the user specific settings of the application. Next, let us look at what is platform as a service, PaaS. So PaaS offers an environment to the users on which they can develop, deploy, configure, and manage applications. It also offers multiple programming models and specialized services um, to build new applications. So multiple programming models and specialized services like data access, authentication, payments are offered to build new applications. So in this, user need not bother about the resources being used. So user need not know that how many processors or how much memory that application would be using. Example, Google App Engine offers scalable environment for developing and hosting web applications. So let us look at this. In platform as a service, the consumer does not manage or control the underlying cloud infrastructure like network, servers, operating system, and storage. However, user has a complete control over the however, user has complete control over the deployed application and possibly configuration settings for the application hosting environment. So this is a much broader service compared to software as a service. Infrastructure as a service. Infrastructure as a service, that is IaaS, offers virtualized resources to the user on demand. Virtualized resources are like computation, storage, communication, etc. And these are offered to the users in as virtual machine instances or virtual storage. So the capability provided to the user is to provision processing, storage, network, and other fundamental computing resources. So in this, the user can start, stop, configure, manage these resources as they require. User is able to deploy and run operating system and application on these resources. The consumer does not manage or control the underlying cloud infrastructure. However, user has control over the operating system, storage, and deployed applications, and possibly limited control over selecting network component like firewall. Infrastructure as a service enables firm of any size to access same level of infrastructure. Okay, to sum up, let us look at the cloud computing reference model. So if we see here, we have users here who access the services which are provided by the cloud. That is any of these services which is provided by the cloud provider through Web 2.0 interface. So these services can be software as a service or platform as a service or infrastructure as a service. If you look at this software as a service, it consists of end user applications, scientific applications, office automation, photo editing, CRM, which is customer relationship management, then social networking. So these are all the applications which are provided as a service to the users, and it is called as software as a service. Examples are Google, Facebook, etc. Next, platform as a service, it provides runtime environment for the application deployment and data processing platforms to the user. So on these platforms, the users can build, deploy their applications. Examples are Windows Azure, Hadoop, Google App Engine, Aneka. Finally, infrastructure as a service. It offers virtualized service, storage, and networking to the user. Examples are Amazon Elastic Cloud Compute, which is EC2, S3, Simple Storage Service, RightScale, vCloud, and many more. Finally, let us look at the cloud stack. So this blue here shows, blue color shows the blocks which the users has to manage, and the red shows what the service provider has to manage. Let us start with software as a service. When software as a service is being offered to the user, everything right from application data, runtime, middleware, operating system, virtualization, server, storage, and networking is managed by the cloud provider. So users will only use the particular application. They do not manage any of these. For platform as a service, the user is allowed to manage application and data. Rest everything will be managed by the cloud provider. Infrastructure as a service allows user to manage application, data, runtime, middleware, and operating system. User can install and choose and install their own operating system on the virtualized machine which is allocated to them. However, the virtualization, server, storage, networking is still managed by the cloud provider. Whereas if there is an on-site server, then everything right from application to the network has to be managed by the user itself. So in this lecture, we have seen the 4 deployment models and 3 delivery models which have been specified by NIST. We'll be looking at these delivery models more in detail in the coming lectures. These are the references. Thank you.